This program, the second in this series, will cover the electrical switches, solenoids, and motors found on GS series pin setters. The GS92, GS96, and GS98 pin setters have a number of switches to monitor, protect, and control the pin setter. Starting with the switch cluster located on the right frame of the pin setter, you'll find switches A through D. Their primary functions are to inform the pin setter CPU of the position of the setting table. The A micro switch is held closed by an actuator when the table is up in the home position. As the table lowers and raises, a small magnet mounted on a cam will close the contacts on the B, C, and D switches. The cam and actuator are designed to activate the switches either clockwise or counterclockwise. An elevator control switch is located on the left rear frame of the elevator. The rollers on the pin shovel shaft pulse this switch as they pass by. It must be pulsed at least once every 6 seconds, or it will stop the pin setter operation. Located on the front left side of the pin setter is the G switch, which is closed by the attenuator when the sweep is down in the guarding position. This must be actuated before the table can be lowered. There are 3 switches located in the mechanic's rear control box. The first is the set switch. It causes the table to lower onto the pins and detects, sweeps, and resets an identical combination of pins. This is helpful when service is required when a combination must be saved. Pushing the reset switch causes the pin setter to cycle to the next ball. On the bottom is a high voltage stop switch. This on-off toggle switch gives the mechanic the ability to shut off the pin setter from the rear. The out-of-range switch can be found on the right-hand guide tower. It informs the pin setter CPU if the table is lowered to its proper detecting height. If it cannot, the pin setter will stop. You must now turn off the pin setter, clear any fallen pins on the pin deck, and turn it back on to resume operation. Each pin setter has 10 pin holders in the setting table. On GS92 and earlier pin setters, each pin holder has one switch, which serves 2 purposes. First, during detection, the switch is activated when the pin detector plate is pushed up by a pin. Second, it will be activated when a pin is loaded from the pin station into the pin holder. On GS96 and later pin setters, each pin holder has 2 switches. One detects the pins during the detection stroke, and the other lets the pin setter CPU know when a pin has been loaded. This allows the pin setter to make a detection with a pin in the pin holder. This upgrade allows the 7 and 10 pin to be double loaded and all 10 pins to preload during predetermined times in a pin setter cycle. The spotting tong switch is located on the right side of the setting table and lets the pin setter CPU know if the tongs are open or closed. The small cam on the toothed rack will close the switch when the tongs are open. Mounted on the right side of the pin setter is the sweep motor switch. It will close when the sweep wagon is forward. Activating the switch turns the sweep motor off and causes the brake to stop the sweep before lowering the table. The table safety switch, TS1, is located on the back left side of the pin setter frame. It is a jam switch, activated only when the pin holders are unable to return to the horizontal position after setting new pins. A roller on the rear swing shaft of the setting table must overpower a spring tension actuator arm to close this switch. When this switch is closed, the pin setter will stop immediately. It will not restart until the problem is corrected. When the TS1 jam switch is activated, you should be aware that the table motor will reverse direction and lower the setting table until the C switch is closed. The pin setter will then stop for a mechanic's assistance. The TS2 switch is mounted on the top of the table guide tower. If the table is unable to return to its home position, it will activate this switch while the table motor is still trying to raise the table. The chain pulls the sprocket and shaft down and overpowers the tension spring, causing the TS2 switch to shut off the pin setter immediately. If your pin setter has the updated software, the table motor will reverse direction and lower the setting table until the C switch is closed. The pin setter will then stop for a mechanic's assistance. The pin count switch will be found on pin setters with a Smart Shark assembly. When pulsed, the switch will send a signal to the pin setter CPU. The CPU then energizes the shark solenoid, which positions the shark fin. The position of the shark fin directs the pin into the left or right distribution lane. Now, we'll examine the two types of solenoids used on GS series pin setters. The first is an intermittent duty type that is colored black. The second is the red solenoid that is continuous duty and capable of being energized for up to 90 seconds. A ball door solenoid locks the ball door for 3 seconds when a ball is detected. This will prevent pins from entering the ball accelerator. When a ball is detected or someone presses the set or reset button, the sweep release solenoid is energized. This lowers the sweep wagon. The purpose of the stroke limiter solenoid is to briefly pull the stroke limiter plate rearward. This lets the T-stop clear the stroke limiter plate, allowing the table to lower fully. The swing shaft latch is also released, allowing the pin holders to go vertical while the table is lowering. When activated, the spotting tong solenoid engages a gear clutch assembly. This causes the table drive gear to close or reopen the tongs. This movement will depend on which direction the table motor is turning. 10 red pin holder solenoids open the grippers on the pin holders while pins are being loaded or released onto the lane. On GS96 and later pin setters, the shark solenoid is used to control the shark fin guide. When the solenoid is energized, it directs the pins into the appropriate distributor lane. A universal electronic control system controls and operates the GS92 and GS96 pin setters. Consisting of several control boxes mounted on the front of the pin setter, the system is capable of working with all voltage systems throughout the world. Mounted on the front of each pair of pin setters, you will find a high voltage box. On the left pin setter, there will also be a game setter box and a common box. The common box is the entry point for the three-phase power. The common box distributes three-phase power to both high voltage boxes for the pin setters and the ball accelerator. A step-down transformer inside the common box supplies several low voltages to the printed circuit board. Also mounted in the common box, the ball accelerator contactor controls the three-phase power to the accelerator motor. Please refer to your manual for a detailed explanation of how the common box is configured. The high voltage box takes the three-phase power from the common box and uses it to operate the distributor, sweep and table motors, the pin light, the pin setter solenoids, and the masking unit lamps. The universal game setter box, which receives all its switch information through the high voltage box, is the central control unit for a pair of pin setters. It accepts and reads all incoming information from the switches, ball detectors, foul units, and the player control station for each pin setter. It then directs the motors, solenoids, and relays to perform certain functions at specific times. A detailed description of all its functions is located in your manual. The GS98 pin setter is controlled and operated by a consolidated electronic control system. This system consists of two control boxes mounted on the front of the left pin setter. On the bottom is the high voltage box. On the top is the low voltage box. The consolidated high voltage box receives the incoming three-phase power and makes it available for all motors, the pin lights, and 3 transformers, which supplies low voltage to the consolidated low voltage box. Refer to your manual for detailed operation. The consolidated low voltage box consists of 3 printed circuit boards, 2 I/O PCBs, 1 for each lane, and the CPU printed circuit board. This assembly is considered the brains of the pin setter. Each low-voltage I/O printed circuit board receives the incoming switch information and passes it to the CPU. The CPU then makes a decision and sends commands to the pin setter motors, solenoids, and relays through the I/O boards. The I/O boards also protect the pin setter solenoids and relays. Consult your manual for a detailed explanation of the I/O PCB. The CPU printed circuit board is the central processing unit or brains of the pin setter. It accepts all information from both I/O boards and processes it to determine what each pin setter must do. The CPU contains a microprocessor which makes the decisions and an EEPROM which the microprocessor communicates with to receive the operating procedures and rules. Consult your manual for a detailed explanation of the consolidated low-voltage box CPU. 2 sets of switches are used to turn the pin setters on and off, as well as set and reset the pin setters. The key switch is used to enable the pin setter to diagnose pin setter problems. It can allow different pin combinations to be set and is used to return the pin setter to its normal 10-pin mode. One of the pin setter CPU's functions is detecting a ball rolling down the lane. The CPU receives its information from the ball detector, which uses a combination transmitter-receiver unit mounted on the ball return capping. This sends a beam across the lane to a retroreflector. When the beam is interrupted, a pulse is sent to the pin setter CPU. The foul detector works on a similar system which alerts the pin setter CPU when a bowler crosses the foul line. Several other switches are also involved with the electronics of GS series pin setters. The bowler's reset allows the bowler to cycle the pin setter to the next ball. The masking unit switch, located on the bottom of the masking unit, can be used to turn the pin setter off. The manager's control unit is located at the front desk of the bowling center and is capable of turning all pin setters on and off individually. Some GS pin setters feature a player control station. It has 2 basic functions, one to display pinfall information and the other to allow the bowler to select the pins they want to bowl against. The second feature is active if the pin setter is in the figures or figures clearing mode. Diagnostics and troubleshooting. The Universal Game Setter and Consolidated CPU have the ability to diagnose pin setter problems, shut down the pin setter, and turn on the trouble light. You can check the switches on the pin setter to verify they are working properly and that the wiring between the control boxes is correct. This is done by placing the pin setter into a contact closure diagnostic mode. Consult your manual for the procedure to start contact closure diagnostics. When an intermittent jam or failure has been reported, you can use the machine cycle diagnostic mode to put the pin setter into a continuous 10-pin bowling cycle. In this mode, the pin setter will set, reset, sweep, and reload pins until the problem can be identified. Please consult your manual for diagnostic mode procedures. When the pin setter stops and the trouble light is on, an LED display located on the top of the Universal Game Setter box or Consolidated Low Voltage box will show the error code that was detected. Review these error codes in your manual for future reference. In this tape, we've covered switches and solenoids, electronic assemblies, and diagnostics and troubleshooting. Please review this tape and become familiar with these sections in your manual so that service or maintenance can be performed correctly.